Welcome back to Chapter 2, Tables and Graphs. This is going to be the last lecture of Chapter 2. So we have two more examples that I want to do, and it's just going to be practicing reading and interpreting two different graphs. We're going to look at a pie chart and we're going to look at a histogram, because I think it's really important that not only are you able to construct a histogram or read a frequency table or construct a frequency table, I also think it's equally important to be able to look at a graph and read it and answer questions. So that's what we're going to do with these next two examples. I also want to point out that there are other graphs in this chapter in the book that, such as frequency polygons, ogives. We're not going to cover those graphs. There's a lot. So it's kind of just too much to cover in one chapter. But I think it's sufficient that we're going to cover the stem and leaf, which I already did, the histogram frequency tables, and I'll give you guys an example of a pie chart, and then we'll read a histogram. So that's all you guys are going to be responsible for in this chapter. Your homework will cover the same, and any future tests or quizzes, this is, what will be included, nothing more in terms of chapter 2. So let's look at example 6. The following pie chart represents last year's expenses of a permanent makeup salon in Queens, New York. The total expenses for the year were $657,234.07. So this total expenses for the year is being illustrated in this pie chart. And a lot of you have seen pie charts before. It looks like a pie, right, with different pieces, where each piece represents a different category of an expense, right? Because expenses aren't just one thing. Like in this case, for this business, payroll's an expense, and that makes up about 42% of their expenses. Another piece of the pie is commissions, which is about 12% of their expenses. We have supplies, we have rent, we have taxes, and then we have other. So these are all the different categories that make up expenses for this particular salon. And we interpret it by reading what percent each category is worth, right? For a total of 100%. So let's answer some questions. So part A says, in which category was the salon's largest expense? So you guys should be looking for the largest piece of the pie, right? That's the highest percent, which in this case is payroll. So payroll is going to be the salon's largest expense at 42%. Part B says, what percent of the salon's expenses were paid towards supplies and rent last year? So we want to look at supplies and we want to look at rent. And my question is, what percent went towards rent and supplies? So we have to add the two together, right? So supplies was 12%. Plus rent, which is 6%. So if we add them together, we're going to get a total of 18%. So these aren't very difficult to read and interpret, these pie charts. They're pretty straightforward. You just have to pay attention to what the question is asking for. So let's look at part C. So part C says, how much money did the salon pay in taxes last year? So let's get rid of these circles. Let's look at taxes. So here's the piece of the pie that makes up taxes. And taxes is 23%. But I didn't ask what percent did the salon pay in taxes, right? That would have been 23%. I'm asking how much money. So we have to think about, okay, 23% of all the expenses is taxes. So how much money is that? Well, let's go back to the beginning of the problem. The total expenses was $657,234.07, right? 23% of that total was taxes. So we have to figure out what 23% of $657,234.07 is. And this will be a nice little review in terms of taking a percent of a whole. So you might have forgotten how to do this. So whenever we want to take a percent of a whole, we have to convert the percent to decimal form. And we did that a few videos ago, right? So 23% is equivalent to 0.23. So we're going to take 0.23. And think of means multiplication. So 23% of the 657 to 3407. So we're going to multiply. So we have to multiply that 0.23 by the total, which is the 657 to 3407. And that we could plug into the calculator, and we'll do that together. So let me share my calculator screen. So we're taking 0.23. And we want to multiply that by the 657 to 3407. And let's round to the nearest cent, which is going to be two places. So we end up with $151,163.84. So that's how much was paid in taxes. That's what 23% is equivalent to. So my answer in dollar amount is going to be 151, 163, 84. So that's the total amount that was paid in taxes. And there's one more part, part D, very similar to part C. How much money did the salon pay in total commissions and payroll last year? So now I want to know, okay, those two pieces of the pie represented how much money? So commission, first we have to see what the total percent is, right? So commission is going to be 12%. And payroll is going to be 42% for a total of 54%, right? So 54% in commissions and payroll. But we have to take 54% because I want the money amount. How much money is that? And again, that's 54% of the total expenses, which is the 657 to 3407. So we have to take 54% of the 657 to 3407. And we're going to do it the same way we did in the previous part. So convert 54% to a decimal. So that's going to be 0.54. And we have to multiply that by 657 to 3407. And we could do that together in the calculator. So I'll share my calculator screen. So we're going to take 54%, so 0.54 times the 657 to 3407. So we get about, if we round again to the nearest penny, we're going to get about $354,906.40. And we'll write that down. So it's going to be about $354,906.40 in commissions and payroll. So that's what I expect you to be able to do when you read a pie chart. You should be able to answer questions similar to what we just did. So moving on, there's one more example that I want to cover with you, example 7. And this is going to be practice reading a histogram. So the histogram below represents the calories in a breakfast item at McDonald's. So you'll see on the horizontal axis are my class boundaries, and those are calories. So those are my calorie intervals. And then the height is the frequency. So part A says Find the total number of breakfast items that are represented in the graph. Now, we don't have a data set. I wasn't given the calorie content of every single item, on the breakfast menu at McDonald's. Instead, I was already given the organized data set as a histogram. But we could work backwards because remember what this histogram represents. The height of each bar is the frequency. It's how many items had between, for example, in the first set of class boundaries, 149.5 and 256.5 calories. So the height of that first bar is 3. And if it's helpful, you could write it in each rectangle. So that means that there was 3 breakfast items that had between 149.5 and 256.5 calories. The height of the next bar or rectangle is 4. So there were 4 items that had between 256.5 and 363.5 calories. And we could do that for the rest of the bar. So the next bar has a height of 8 items. The next bar has a frequency or a height of 3. And then the last bar has a height of 2. So that represents the frequencies, how many data values, right, fall within each class boundary. So if we want to get the total number of breakfast items, we have to add up all these frequencies. So we're going to have 3 plus 4 plus 8 plus 3 plus 2. And that's going to be 20 items. So there were 20 breakfast items that were used in this data set. How many breakfast items have more than 470 calories? So here's the class boundary for 470. And we want more than 470. So we have to look to the right, right? Anything to the right of 470 or 470.5 is going to have more than 470 calories. So that includes these last 2 classes, and that's a total of 5 items, right? So we have 3 plus 2, which is going to be 5 items, have more than 470 calories. So let's look at the next question. So it says, what percent of the breakfast items are in the first 2 classes? So here's my first 2 classes. And the heights of the bars are 3 and 4. So there's a frequency of 3 and a frequency of 4. So if we add that together, 3 plus 4, that's going to be 7 breakfast items. But I wasn't asking how many breakfast items are in the first 2 classes. I was saying what percent of the breakfast items are in the first 2 classes. So that's 7 out of how many altogether? How do I convert that 7 to a percent? Well, remember, there's 20 items altogether. So this is going to be 7 out of 20. And we could divide that out in order to get the proportion, right? So what's 7 out of 20? So if we go to the calculator and we do 7 divided by 20, we get 0.35. And I want you to convert that to a percent. What percent of the breakfast items are in the first 2 classes? And we did that a couple of videos ago. So remember, we multiply the decimal by 100 or we move the decimal to the right 2 places. So that's going to be 35%. So we could say that 35% of the breakfast items are in those first 2 classes. Let's look at part D. Which class has the smallest frequency? So the smallest frequency is going to be the one with the lowest bar, right? The rectangle, that's the lowest, which is going to be the last class, right? So we can either say the last, because it's the last one, right? Or it's the 5th one, because we have 1, 2, 3, 4, 5 classes. So it's going to be the 5th class. Or we could also say the last class. The next part says, what percent of the breakfast items have more than 256 calories, but less than 578 calories? So in other words, it has to be between 256, right? Because more than 256, but less than 578. So let's get rid of the writing from the previous question. So here's the class boundary for 256. And then 577.5 is going to be the class boundary for 578. So we want more than 256, but less than 578. So that's going to contain those three classes in the middle. So we're going to add up those frequencies, right? 4, 8, and 3. So that's going to be 15 breakfast items. But again, I want you to tell me what percent that is. So this is going to be 15 out of the 20 items, right? Part of a whole. And that we could divide out in the calculator again. So we're going to take 15 and we're going to divide that by 20. And we're going to get 0.75. Which is equal to 75%. So 75% of the breakfast items have more than 256 calories, but less than 578 calories. And then the last part, F, says, what percent of the breakfast items have less than 150 calories? So this class boundary of 149.5 is the cutoff for 150, but we want less than 150. So we have to look to the left because that's less than. But there's no bars out here, right? There's no frequencies out here. The first bar starts at 149.5 and it gets bigger, right? So it really starts at 150. So there are no breakfast items that have less than 150 calories, so 0%. So this is a nice example where you have to read and interpret a histogram. This is as crazy as the homework questions would get, or a quiz question or a test question. I just think it's really important that you're able to look at a histogram and be able to read it, answer questions, interpret it. Before we end this lesson, the only other thing that I want to point out, because you are going to see this in the homework, in the practice questions that you're going to do in my stat lab, is that sometimes a histogram will have relative frequency as the vertical axis. So like notice in this case, the vertical axis was frequency, right? Or count. But sometimes you might see a histogram that has relative frequency as the vertical axis. So instead of the count, remember, the relative frequency is just the proportion. So instead of 1, it would be 1 out of the total number of items, right? Which is 20 in this case. So we could think of this as 1 over 20. 2 would be 2 out of 20. And we could write these as decimal numbers. So you're going to see that in the homework. So for example, 1 out of 20 is 0.05. So my vertical axis could be relative frequency, and we're going to start at 0.05. 2 out of 20 is 0.10 or 0.1. 3 out of 20 is 0.15. 4 out of 20 is 0.20, and so on and so forth. So it is possible, and I don't want you to get confused, that when you're looking at the homework questions, rather than the vertical axis being frequency, the vertical axis might be relative frequency. So rather than the count, it's just going to give the relative frequency as a decimal number. And I don't want that to be confusing to you, okay? So you might be looking at proportion instead of count. So in the next lecture that I do, we're going to start chapter 3.